Hello dear students, NEET 2021 will be held next month, September 12th. So let me upload few videos on pulley systems and let me tell you the tricks how to solve it quickly in 1 minute. I'll be uploading about 10-15 videos. So in case it happens that you get a numerical problem on pulley system, you will be able to answer it in less than 1 minute. So first let me begin with a simple pulley with two masses hanging from it. The pulley is fixed. Now look at the diagram. The pulley is fixed and the mass of the pulley is not considered, and there is a string going all around it. The mass of the string is also not considered. For NEET examination, mass of the pulley and the mass of the string are neglected, right? So now look at the diagram. Here is a mass, let it be M1, and this mass is equal to M2. I have drawn it slightly bigger in size than M2 because if let's say M1 is 10 kilograms, M2 is 2 kilograms, then definitely M1 will fall down. So due to the pull of the earth, the weight of this mass, which is a force, is vertically downward. It will be M1 times G, and the weight of this mass M2 due to the pull of the earth is also vertically downward, that is M2 times G. I have considered M1 the magnitude of M1. I mean the M1 is heavier than M2, so this one will fall to this side with acceleration and this one side will move with upward with acceleration. The length of the string from here to here is fixed, means it is not a stretchable string. So if this mass falls by a distance x, the mass M2 will move up by the same distance x. So as you can see from here, this is the string that is going around over the pulley. The tension in this string and in this string, it is the same string, will be same. Let it be T and let it be T. Why it is away from M1 and why it is away from M2? Because if you take a string and try to push somebody, you cannot push somebody with a string, but you can tie the string with a mass and you can pull it. Means therefore it is away from the mass. And if you consider the pulley, the same tension here for the pulley is to this side, and here the same tension for the pulley is to this side, right? So this pulley is being pulled downward with the two forces T and T. So since it is an equilibrium, it is not moving, so here the tension will be 2 times T in this support which is holding the pulley. Now you can write equations of motions on this. Since it is coming down, the net force on this is M1 minus T. So then you will write M1G minus T is the net force on this. So it will be equal to its mass into acceleration, equation 1. And if you look at the second one, since it is going up, so the value of T, magnitude of T must be more than the M2 times G. So for M2, I write T minus M2G will be equal to the mass of this times the same acceleration. So there are two equations and two variables. If you add it, T cancels. If you take a common on this side, we are left with M1 plus M2. On this side, if you take common, we are left with M1 minus M2 times G. So your A comes out to be M1 minus M2 over M1 plus M2 times G. Now put this value of A either in equation 1 or in equation 2 to get the tension as 2M1 M2 by M1 plus M2 times G, right? So that's a lengthy process. How to do it faster? So what you have to do, then you have to imagine this mass and this mass m2, you make them horizontal. You think as if they are like this, and this m1 g is to this side. This is the shortcut. If you make this mass horizontal, like this, then m1g is to this side, and if you make this mass m2 horizontal like this, then to this side is your m2g, and here is your tension in between the two masses m1 and m2. Don't consider this. This is an internal force. So on this system, the net force is to this side, m1g minus m2g is the net force, divided by the net mass, that is equal to m1 plus m2. So force over mass is nothing but your acceleration, and this expression is same as this, because if you take g common, you are left with m1 minus m2 by m1 plus m2 times g. Now to find t, you need to put this value of a in either equation 1 or 2. This is the shortcut for finding acceleration only, right? So that is how you can do it. And if the pulley is fixed, the acceleration on the both sides will be same. Means if this is falling down with acceleration a, this will move up with acceleration a. So this is how you do it faster. I'll be uploading few more videos in the evening, and go through that. You'll be able to answer questions very easily on pulley systems. Thank you.